Hi there! Today we're going to take our Matplotlib figures to the next dimension. That's right, we're going to be plotting in 3D. So let's get started with the Matplotlib code. First, I'm going to import the pyplot module as well as NumPy. I'm using NumPy's random module to create some X, Y, and Z data, and I have 50 points in total. I'm also going to use the RC parameters to update the figure size for all of the figures that I make. There are several different 3D plots you can make with Matplotlib, but let's go ahead and start by creating a scatter plot. Whenever I want to plot something in 3D with Matplotlib, I'll first need to start by creating a set of axes. So we're going to reference pyplot and this axes function. Then I'm going to use this keyword called projection. This will tell Matplotlib that I'm going to create something in 3 dimensions. So let's go ahead and see what that does by itself. This creates my 3-dimensional axes, and now I can add data to these axes. So let's go ahead and name this something. Let's call it ax. And if we go ahead and check the type of ax, we'll see that these are subplot axes, and more specifically, these are 3D subplot axes. Okay, so once we've got our axes set up, it's time to go ahead and add some data. So we're going to do this by referencing those axes and then using this method called scatter 3D. Now I just need to pass in my X, Y, and Z data for these points. Awesome! Let's see all of those points represented here in 3-dimensional space. For this particular example, it's kind of difficult to tell which one is the x-axis, the y-axis, etc. So let's go ahead and label those. I'll reference my axes, and then I'll use this setXLabel method, and I can just pass in a string here. Let's call it x. So my x-axis is actually this one, and I can go ahead and do the same things for the y and z. Okay, so here's my x-axis, my y-axis, and my z-axis. And of course, you can label these whatever makes sense for your use case. And you may also decide that you want to style these scatter points. And luckily, the syntax for styling these is going to look very similar to what we would use for a 2-dimensional scatter plot. For example, if you want to increase the size of these dots, you can reference this s argument and increase that to say 100. So we just saw that we can label our x, y, and z axes, but what if we wanted a different configuration for these? By that I mean, what if I wanted to rotate this 3-dimensional figure? Well, I can do that using this method called viewInit. So let's go ahead and try it out. We'll reference our axes again and use viewInit. So this method will want 2 arguments. The first is going to be the angle of our elevation, and the second one is going to be the angle of our azimuth. So let's go ahead and try them out. Let's see that we actually switch both of those to 0 for now. Alright, so here's what we see. We have the y-axis going to our right, the z-axis pointing straight up, and the x-axis is pointing straight back into the page. This isn't super helpful to display 3-dimensional data like this, so let's go ahead and play around with those angles. First, let's change the elevation angle, and this is going to be represented in degrees, not radians, so let's say 45 degrees tilting downward. Great. So now you'll see that the z-axis has just rotated a bit off of the page, and we're able to see a little bit better those x and y dimensions. Well, we probably also want to rotate this figure across the horizon, and that's our azimuth angle. So let's go ahead and change that to be 215. So this configuration is different than what we saw before. Now our x-axis is pointing this direction and our y-axis is pointing the other way. So you can use this viewInit method to rotate that figure however you'd like. Besides scatter plots, you also have the option to create 3D line plots. So now I'm going to create some new data to show off. I'm creating a z, which is just a linear space from 0 to 10. And then I'm creating x and y based off of the cosine and sine of that z line. I have my axes already set up, so we reference these axes much in the same way for the scatter plot. Now we just say axes.plot 3D, and this is going to give us a line plot instead. We'll go ahead and pass in our x, y, and z data. So now we have a nice spiral forming, and we can see this represented in 3-dimensional space. And just like with the scatter plot, you can go ahead and style this line using the same keywords that work for a 2-dimensional plot. For example, I can change my line width and make this spiral a little bit darker. And just in case you're curious, I have this extra argument called omega. This basically just controls how many spirals I'm seeing on this figure. So if I increase it to 4, I'm going to see more spirals in my figure. So besides building those super cool 3D scatter plots, you can also use Matplotlib to create three-dimensional surfaces and wireframes. So let's check that out in the Matplotlib code. So let's try to create a surface plot with Matplotlib. And specifically, whenever we have one of these surface plots, we should have an idea of what our function is. By that I mean, here in this example, we're going to try to plot z equals 50 minus the quantity x squared plus y squared. So my first recommendation here is to go ahead and define this value for z as a function. So let's create a function, we'll call it function z, and this function will take in an x and y value. It should return the function that we're trying to plot, this surface. So that's going to be 50 minus the quantity x squared plus y squared. Okay, so I'm definitely going to recommend that you have z set up in a function like this because we're going to need to calculate this value for many, many points across a grid. Our next step is to set up that grid. So in this example, I'm going to use 50 points along the x-axis and the y-axis. So I'm just using linspace to create 50 intervals between -5 and 5 for both x and y. But then instead of having just x and y values, I actually need to create a grid. So we're going to call that capital X and capital Y, and I can create this pretty easily using NumPy's meshgrid function. For meshgrid, all we have to do is pass in our x values and our y values. So what has this done? Let's take a look at capital X. This has actually created our x values over and over and over again. It's just repeated them. And so if I were to take a look at the shape of x, we are now talking about a 50 by 50 matrix. So we have 1 point across this entire grid for every combination of x and y values. So you can basically just imagine here, I'm just creating a grid. Let's go ahead and plot out the scatter plot of x and y. I just have 1 point for every single place on this entire grid. And my goal now will be to compute my function z for every single location across this grid. So let's go ahead and do that. It's pretty simple. Because we have z defined as a function, we just call function z on our x and y grid. Now, these z values are also the same shape as x and y. That is, we have x, y, and z positions for all 50 by 50 grid points. So let's go ahead and create a surface plot for these x, y, and z data. So I'm going to start off doing the same thing that I did for the 3D scatter plots. I'm just going to create a set of axes and let Matplotlib know that I'm going to be creating three-dimensional axes. But now, whenever we reference these axes, we're going to use a new method called plot surface. And we just pass in our x, y, and z grid data points. Awesome! So this shows us exactly what that surface looks like. So because we have that grid across the x and y axes, we can now create a surface for the z dimension. And that surface matches up with that function that we initially described, 50 minus the quantity x squared plus y squared. You also have the option to create a wireframe instead of a surface if you'd prefer that aesthetic. So the code is going to look very similar to the surface. You'll create some x and y values, and then create a grid as well as pass in those values to your function for z. Then you'll have a set of axes just like this one, and instead of doing a plot surface, you'll just reference those axes and say plot wireframe. Pass in x, y, and z, and there we go. So you can see that this just doesn't have the middle part filled in. We have a wireframe rather than a surface. By the way, we can change the aesthetics of this wireframe dramatically if we change the number of points on our grid. So right now we have 50 points on the grid, but let's say we reduce this down to 10. Now when I execute my wireframe, you're going to see a totally different aesthetic with a lot more space in between these, and this is really just because we've changed the size of our grid. So if I take a look at X, now we actually have a 10 by 10 rather than a 50 by 50. So it just depends on kind of what look you're going for and what granularity you want for this wireframe. Also, remember that you can continue styling this however you'd like. Let's say we switch this color to black, and we could even increase those lines if we prefer. And you may also decide that you want to be able to interact with your three-dimensional plots. To do that within a Jupyter notebook, you'll want to use this magic command that is %matplotlib space notebook. And then the code's going to look the same as what we've seen before. You'll just want to include this additional line that says fig equals pyplot.figure, And this is just going to help you create one interactive figure for each of the plots that you want to make. So let's go ahead and execute this. So this is going to look exactly like the scatter plot that we made before, but now you have the option of taking your mouse, clicking on this figure, and dragging it around if you'd like to see a new angle. You also have the option of hovering over these points to see what their approximate values are, because you're seeing what X, Y, and Z values your cursor is at for each of these points. And here's this wireframe that we talked about before. The really nice thing about these wireframes or surfaces, now you can drag this around and see all the different angles of your surfaces. So I hope you've enjoyed learning all about 3D plots in Matplotlib, and I hope you've also had some creative ideas about how to incorporate these into your own data visualizations. Thanks so much for joining me, and I'll see you next time.